Okay, next on our list is this thing called rationalizing the denominator. If the denominator in a fraction is a surd, we can get rid of it to neaten things up. We use this rule. Root A on root B times root B on root B equals root AB on B. What you'll notice is if we have a fraction that looks like this, all we're doing to it when we multiply it by root B on root B is multiplying it by 1. Anything divided by itself is 1. So really, we're not changing the value of the fraction, we're just changing its form. And in particular, we're getting rid of this surd in the denominator, because notice that here, that's just a whole number in the denominator rather than a surd. And that's the whole point. It's turning the denominator into a rational number. Cool. All right, so examples. E.g. Express with a rational denominator. That's how it would normally say it. Express with a, or it would say simplify or something like that. Rational denominator. Basic one. 1 on root 3. Okay, so to get rid of that root 3 on the bottom, we're going to multiply through by root 3 on root 3, because root 3 on root 3 equals 1. How do we multiply fractions together? We multiply numerator by numerator, denominator by denominator. 1 times root 3 is root 3. Root 3 times root 3 is 3. Done deal. Okay. Let's do a bit of a harder one. Let's look at another example, something like question 11 from SURDS exercise 2. I might do 11E. It looks like this. 3 root 5 plus 6 root 7 on root 8. We want a rational denominator, we want to get rid of the root 8. So what do? We multiply by root 8 on root 8. Okay. Not an issue for the bottom. Root 8 times root 8 is 8. But what happens to the top? Well, we've got root 8 multiplied by this whole thing. 6 root 7 on 8. Now we have to expand this guy. So root 8 times 3 root 5, thinking back to our multiplication rules, is going to be 3 root 40. Root 8 times 6 root 7 is going to be 6 root 8 times 7, whatever that is, 56. On 8. And then probably you can simplify the root 40 and the root 56 further. 2 root 10. Root 56 is 2 root 14. And final cleanup, 6 root 10 plus 12 root 14 on 8. Finished. Bit of work in that, but not too hard if you know the individual bits. Cool. Next example, something like question 12 from exercise 2. These ones use a bit of a different rule from what I said up above, so pay careful attention to this one. If we want to rationalize the denominator for something like, we'll do b, 12b, 1 on root 8 minus root 5. We can't just multiply by root 8 minus root 5 over root 8 minus root 5. It's not going to work nicely. Okay, we have to take advantage of this rule from algebra, which hopefully you've learnt earlier this year. It's this one. It's a squared minus b squared equals a plus b, a minus b. So if we multiply this by root 8 plus root 5 and root 8 plus root 5, then the top is just going to equal 1 times this. That's not really an issue. But down the bottom, we're going to have root 8 minus root 5, root 8 plus root 5, which by this rule over here, we can see that it's going to be a squared minus b squared. I could do the full expansion just to prove to you that it's true. Top line, root 8 plus root 5. FOIL expansion, root 8 times root 8, 8. Root 8 times root 5, root 40. Negative root 5 times root 8, minus root 40. Negative root 5 times root 5, minus 5. Plus root 40 minus root 40 cancel, and all we're left with on the bottom is 8 minus 5, which is 3. Root 8 plus root 5 on 3. Actually comes quite neat. But you just got to remember to multiply it by plus instead of minus up here, just to take advantage of this perfect squares rule. Thank you for watching and have a nice day.